Good morning. Welcome to AP Computer Science A, and A is for Advanced. Today we are going to be coding section 1.6, and you guys know that's 1.6 because all of you guys have your notes with you, and you also have gone into the Replay classroom and have access to the coding along activity. Just make sure that you guys are coding along with me so that way you guys can retain some of the information that we're going to cover. Now today we are going to cover something that we actually talked about in section 1.4, which was numeric operations. So let's go through some of the things that we talked about then. Let's go and declare a variable x, and remember the difference between declaring a variable and initializing the variable. In this case, we are declaring the variable, and now quick thing, if by any chance you don't have your this part, go into the little three dots and go all the way down. If it's auto filling some of this code for you, just go and disable it. You don't need it at this time in the class. It's a little distracting and you'll be using it later on, but for now let's go and keep it basic. Now, so we declare it, and now we are going to initialize it. So x is equal to 9, and we initialize the variable. And now let's go get another variable. Let's go and make a variable y. That sounds great. Great suggestion. And now we're going to declare it, and we're going to initialize it at the same time. Let's make it equal to 2. Remember, we've been talking about this, the difference between both of them. And why have we been talking about both? Because this will be on your test. You need to know the difference between declaring the variable and initializing. Or now we want to be able to do both of them at the same time, right? This is my preferred way to be able to do both. You can still do it this way, but that was more introduction. And there's a reason why, because once we go into memory allocation, we can discuss what happens, and which will be very interesting. But for now, I prefer if you do it the second way. And one of the things that we talked about was if we divide. So let's say I have n z equal to x divided by y, which is 9 divided by 2. And now let's go do a system.out.print. Let's go and print system.out.print ln. We're going to say the number z is equal to plus. What is the action when we connect two strings together? It's concatenate. And I know what you're saying, hold on, Diaz. You say concatenate two strings. Well, Java is going to be connecting those. This will convert this to a string, and it's going to concatenate with the literal string, or the string literal, the number z equal to. And let me not forget but just be careful. That is concatenate, and we can concatenate a string using the print statement. But for now, just think about concatenate. Don't worry about the rest too much. And now, if I run, it's going to be 4, right? We expect it to be 4.5, but at this point we know that's not 4. Why? It's not 4.5, it's 4. So why is it 4.5? That is the question. We need it to be 4.5, but it's 4. Remember that Java is going to evaluate this. That's an int divided by an int. It's going to allocate int memory, which is only 32 bits, which is not going to have space for the decimal. So it cuts it off. So now it's 4 instead of 4.5. And I know some of you guys will say, well, hold on, can I just go and replace the int with a double? It will not work. What do you think? No, that's going to give you 4.0 because it's going to get rid of the decimal. By the time you want to store into a double, it's going to convert it to a double. 4 is an integer, 4.0 as a double. So therefore, how do we fix it? We learned that we can fix it by placing it 1.0 times. Because Java is going to perform this operation first, a double times an integer is going to be stored into a double. Then you're going to divide the double by an integer, it's going to still be a double, and then you can store it into a double. So therefore, if I run this, this will be 4.5, which is what we wanted. Now, remember that we talked about that there were two different ways to be able to achieve this, to accomplish this. That's one way, and you can still do it that way. But now, because I know that all of you guys are advanced, that we can actually do it in a different way. We're going to be casting it, what we call casting it. So what we're going to place, we want it to make it into a double. So therefore, I'm going to place parentheses. I'm going to type in double. And what happens here is that Java is going to make the x into a double right away. So therefore, whenever Java makes the x into a double, it's going to be a, so it's going to make that into a double. And then a double divided by an integer is going to be a double, and then we're fine. So that process is called casting it. You are going to cast the value. Now be careful, because some of you guys might say, so let's go and run it. Did I run it already? Let's see, let's run it, let's run it, let's run it. And that's going to give me 4.5. So that works. Some of you guys might start doing the following. Some of you guys might start doing as follows. And so, will that give me the same result? Yes or no? What do you think? That's going to give me a no. Because in this case, your order of operations, you are dividing two integers together, so it's going to be stored in an integer, and then once you cast it, you already lost the decimal place. So therefore, you want to make sure, undo, undo, undo. You want to make sure that you just place it, because you want to convert the x to a double, and then you can divide it up. So that is casting, and casting can be different, used in different ways. So we can cast an integer to a double, and that's going to give us a double. But let's go and go through another example. We're going to keep the z, and we're going to get rid of everything else. So therefore, this is a double. We are going to make it into an integer. So let's say we have int z is equal to 4.5, and I run it. What do you think is going to happen? What do you think is going to happen if I run it? I'm trying to store a double into an integer. It's going to give me error. Now very carefully, it says incompatible types possible loss conversion from a double to an int. Because the double is 64 bits, it doesn't fit into a 32-bit space. So therefore we cannot do it. But if by any chance you do have it, so let's go and say we do have int x equal to 4.5, and we want to be able to store, or let's say another error, right? So we want it to be a double this, double x equal to 4.5. That is correct, right? 4.5 is a double, we can store it into a double. 64-bit into 64-bit. But now we want to be able to store x into z. We know that that's not possible, and we want to be able to convert it to an integer, so we're going to cast it. That means that Java is going to convert the 4.5 into an integer. So what's going to happen? What's going to be the value of z now? The value of z is going to be error. Well, that should work. What's going on? This semicolon. Oh, you probably saw that. So let's run it. There you go. So therefore, whenever you cast a double as an integer, you're going to chop off the decimal place. So that's going to be very useful when you program and in some of the calling activities that you will have. So if I do 4.9 and 4.9 is a double and I cast as an integer, it's going to be 4.999999999, and I'll cast as it's an integer, it's a double, and I'll cast as an integer, it's going to be 4.999. You guys get the point, right? I can continue on forever. So therefore, another way, let's say I want to be able to get, well, I'll let you guys think about that for the calling activity. I don't want to give too much away. We can also, if you notice on your notes, and we're going to come back to casting once we even go into objects in, but that'll be not to Unit 5. We're going to come back to that in a second. So read through your notes. Notice that we went over how, let me make myself a little larger. We went over what that causes an error, just read through it, what should be the value. You guys will have this chart here. So this is, right now in this class we are using int double. And notice the boolean is isolated because it cannot be cast as anything else. But we can actually cast a char into an int. We can place smaller ones. A char is how many bits? 16. We can cast into an int, which is 32. And a 32-bit can be cast into a double. So that's automatic conversion. There's no, it automatically can be converted. When you go the other way around, that's when you're going to be losing some of, so you're going to be chopping some of the information. We're talking about this briefly in the class. And we talked about truncating, right? Read through this carefully. So, we talked about truncating doubles. And we're going to go over the ASCII character table during class. So, if you have any questions, please email me. I'll see you guys next time. Have a great day.